graduated from BYU in April with a degree in computer engineering. So fun, easy stuff. We're all good. And that's my wife, Rachel, over there. We've been married for about 2 years, right? 2 years in April, or May 14th. What we have here is the diffusal. Oh, I forgot more about myself, sorry. For Perl, I started on Perl. It was my first scripting language because I was working as a Linux systems administrator at BYU, and my boss just loved Perl. Everything had to be written in Perl. He said it's like the duct tape of the internet. Like, it holds everything together, Perl and CGI and such. But then, after I graduated, I got introduced to Python, and then I haven't written any Perl since. So that's how that goes. So this is a project that we took to OpenWest. It's been dubbed the Diffusal Station. I mean, they can if they want, but we don't want to waste their time with all that stuff. But what it is this is an escape the room in a box. So what we got is we have an Arduino, and this is where I'm gonna make use of my camera. Maybe you can see in there. I don't know. Everyone can come up afterwards and look at it more. But what we have is we have a Raspberry Pi, that's the master, and it's controlling the whole box. And then we've got 4 Arduinos plugged into it. And each Arduino controls a different part of the box. We have one that controls the lid. That's just this touchpad that isn't working right now. And this LCD. And then we have our knock kit, what we called it. And that controls the ultrasonic sensor and an IMU and some other sensors. And we have one Arduino dedicated to these lasers. We have some laser tripwires. And every time you start the box, the puzzle is completely randomized. So like the code that you have to enter into this is randomized, the lasers are randomized, and there's some switches in here and a knob, and the values for those are randomized. But we also randomize the clues with it. So you can solve the box in your first try if you're very intuitive and know some things about binary and the like. So yeah, we wanted the box to be able to be solvable, but also have some replayability. So once one person learned how to solve it, they wouldn't just go put out a how-to guide and then everyone would just do it on their first try. So that's why we included the randomizing. What I wanted to talk about a little bit was the structure that went into the bomb. I mean, it's out there, so we'll just go with it. It's the bomb. The first thing is we wanted these Arduinos to be able to communicate with the Raspberry Pi. And the serial was the obvious choice for that. So we have the Arduinos connected with their TX-RX lines into a USB cable plugged into the Raspberry Pi. And so what that does, so that wasn't enough on its own. Let me see if I can refresh. And then I did this when I was new to Python. I was excited. I loved Python when I started this project, but I was still really new, so I would love to just completely scrap this and do everything from scratch with everything I know now. Like do some multi-process threading and stuff like that. But the way I did this is the Arduinos are sending what I call a heartbeat, and that is the serial connection. It's sending the Arduino, each serial line is sending its the Arduino's ID and a message and any data that needs to go. Like it'll say, I'm Arduino number 1, and I'm alive, everything's good, and switch number 2 is flipped. And every second they're sending out the heartbeats. And some other messages are sent asynchronously. So to get an idea of what that looks like, if I go into, I'm SSH into the Raspberry Pi right here. And if I just open Kermit-L TTY USB 2, here I'm starting to get some heartbeats. Well, I got one. So this is Arduino 1 heartbeats alive, is what I decided that message meant. And every time I get one of those messages, it resets a watchdog timer. And if that watchdog timer ever expires, then it means that the Arduino disconnected and the bomb blows up. So you have 1 second after disconnecting an Arduino before the bomb will go off, which Arduino shouldn't be disconnected because that's not part of the puzzle. But if it were, then it would blow up. So then the next part is we used a Python module called Flask to make this web server. And the web server, all Python, it just is linked to sending a few commands back to the Arduinos. And the Arduinos have a loop where they're constantly searching for little messages too. So on my console, I have a list of my Arduinos, my puzzle kit, lid kit, LED kit, and the knock kit isn't here because it doesn't take any commands, it just sends commands to the Raspberry Pi. But now a little disclaimer then, the fusion station, the bomb, it's been through a lot of use. At OpenWest, we were rushing to get it finished in the whole week before. Like we were staying up till 3 a.m. every night until we got it done. And then it went through OpenWest, and then it was done. Like it just stopped working. So it just barely survived OpenWest. And then we had GCC, which was a girls' cybersecurity camp at BYU. And so for another week, we got it up and running again, got it working, and then it barely survived that week. And what I mean barely survived, it's like we had all the sensors working, all the protocol was great for communication, the Arduinos were talking, the Raspberry Pi is talking to the Arduinos, and then all of a sudden the ultrasonic sensor starts reporting bad data. So if you touch the lid or jiggle the box at all, then it blows up. And that was a problem because people couldn't solve it at all. So then we disabled the ultrasonic sensor. And then the laser Tripwire started being finicky and started recording bad data, or just because the box was moved a little bit, the laser Tripwires, it's lasers pointed at photoresistors. And if those photoresistors report a value that's incorrect, then the bomb will go off. And so the lasers got just misplaced a little bit, and it was enough construction that we just disabled the lasers. And then little by little, things started wearing down until not a lot is working right now. But we do have plans to modify it, paint it, make it all pretty for the next OpenWest. But yeah, so from this web console, I would be able to send the start-stop button. This was the magic button. Like when we had people that were operating the bomb, this is the only button we told them to push and leave everything else alone. You started the timer, and then it started ticking down the timer from 10 minutes. And then when it blew up, you hit start timer again, and it reset the timer, and then start again, and it started ticking down again. So we wanted that interface to be very simple, but then we also wanted all these other tools to be able to debug when things went wrong. And so we'd be able to affect any of the sensors or actuators inside of the box with the rest of these buttons. And it would just send a command to the Arduino. So this RGB green is, I have an RGB right here. And if I was to send the command, if it was working, I would choose an RGB color, I'd send the command, and then the Kermit, or the serial connection, would send Arduino to R, and then the color, GRB. And then the Arduino would be constantly looking for that message, and then it would see what color it needed to be, and then it would change. And so that's kind of how our communication protocol worked. And Again, if I was to do this all over again, I would do it threaded. I would do it all kind. I don't know if I would use Flask because web servers are slow and such, but we'll redo everything. Does anyone have any question about the box? Yeah.
Where'd you come up with the puzzles?
Well, the idea first came from, we went to DEF CON 24 and they had a bomb there and we never solved it. I sat in that line for like 6 hours maybe and just tried it over and over again and never got it. And there was what it got to was there was an Indiana Jones head like in the very, very inner part of the box. And then after the conference, my dad was like, Tyler, you just needed to like swap out the Indiana Jones head for something of equal weight. And I was like, oh, duh. Yeah, long story short, they had had something similar at DEF CON. And so we had a whole year before Open West where Victor approved the project and we had money, we had the materials, everything to build it, but we didn't know the puzzles. And so for about 10 months, we were just talking puzzles. And then the last 2 were scrambling to actually build it. And so for ideas, we looked at Keep Talking and Nobody Dies. It's a game on Steam. Yeah, same. Yeah, that one. We looked at that for inspiration and Escape the Room. We went to Escape the Rooms and tried some of those, and that gave us a little bit more inspiration too. The puzzles, since we'll end up redoing it anyway, I mentioned there's the laser tripwires, and to disable the laser tripwires, what you can do is you can shine your own laser onto the photoresistor, and then the laser will report it'll never report being tripped. And then you have an ultrasonic sensor, and so what you would have to do is you have to slip a piece of paper in before you open the lid, and then you open the lid and the ultrasonic sensor thinks the lid is still closed. And then there's a whole bunch of switches in here, and the switches indicate a hexadecimal value which you should put into the keypad. And then you open the keypad, and then you open up the inner box, and then it's a red wire, blue wire, and you have to cut the right one. And there's an indicator somewhere on which one it should be, but that's how it is. Yeah, does that answer your question? Inspiration for the puzzles? Yeah. Any other question about it? Yeah?
Could you go over a bit of the construction, how you assemble the different hardware pieces to work with the software?
Yeah. So it was, for the longest time, it was me and Clayton Ramstead. We were the only ones working on it for a long time. But he did most of the hardware. But first we got all the scrap plywood. My dad's an electrician and he had just tons of wood lying around. And I would have used plywood or cardboard or anything else but this because it is super heavy. If you can, not very easy to move around. But then we also use these, sorry, name escapes me, solderless breadboards. Is that what you call them? Proto boards. Yeah. And if we were to do it again, then I would probably just print PCBs. It'd be a lot easier. We could get a couple of them. But what exactly did you want to know about the hardware then? Sorry.
I'm more interested along the lines of building something similar myself, just for fun of it. And so I'm interested in just general how things are hooked up and whatnot, like what you did for the laser module or...
Okay, I got you now.
For the laser module, you already explained lasers and photosensors, so...
So how do the other ones work?
Yeah.
Okay, now I understand your question more. So after we decided which puzzles we were going to do, then it was getting a parts list together and sending it to Victor to approve so we could buy everything. This box cost about $200 to make, so pretty cheap, I think. Uh-oh. Can't control C that one. Wait for the train to go by. The steam locomotive command, SL. I don't know why I did that, but okay. Yeah, so we decided which hardware components we wanted to put in. And then we spent, I told you it took 2 months to build it, like it was 9 months or so coming up with puzzles and then 2 months of building it. Well, one of those months was just testing the hardware. So we took just the laser tripwires and we calibrated them, and let's see if I have it in here. We have, yeah. So this is the very, very simple laser tripwire script. It doesn't have any of the communication protocol. It's just, this is me getting a laser tripwire working. And then we have similar C code for every single component. Like, we want to make sure the potentiometer reports certain values. We didn't get a discrete potentiometer. We got one that was kind of logarithmic, so it was tricky to get that one working. But then we got the touchpad working individually. We tested each piece.
By itself on the computer?
Right. Made sure that we can do every Arduino piece on its own, and then we compiled it all into, for each Arduino there was a master, master code thing. It's probably in this final Arduino code. Nope, it's not in that one. There's a little bit of confusion about where we were putting stuff. So some people started building the structure in one area, and then other people built it in another area. So it gets a little messy. Here we go. So this is for the knock kit. This one doesn't report anything. It doesn't listen, but it does report. So this one, it will, let's see, a function get distance, receive message, and oh, it does have receive message. It doesn't use it, but yeah. Does anyone else, like when you're like typing in, like you're on Facebook and you're typing someone a message, and then all of a sudden you just type LS a bunch of times, hit enter, and then Control L, yeah. Or you open a Firefox browser, do a, yeah.
Well, that's why there are extensions for that now in browsers, but when you actually do WQ, it saves it to the text box.
You get the Vimium extension.
Yeah.
Let me see, the LED kit is probably the most interesting one. There we go. This is the laser tripwires. It sends a lot of messages. Anyway, that's something you can come up, when we're done here, you can come up and look at the box and you can look at the code. And if you're interested in working on the project, if you're like, yes, I love working late nights and doing things that are near impossible, then it's fun. Yeah?
But did the Arduino solve a problem that you couldn't have approached by just using the pinouts on the Raspberry Pi, for example, and then pulling those, or?
That's a good question. I remember there was a reason for it.
Tripwires, that might be the case, right?
Right.
I can think of two things for that. One is an I/O concern. If everything's going through the Raspberry Pi, if the Raspberry Pi stutters or goes slow for whatever reason because of one of the scripts, then everything is going to be affected.
Okay.
Whereas if you have them all separated, then it separates the concerns. You have everything isolated to their own part, so if one part fails, it's only that one part, not everything.
That's a good answer.
Better answer than I would have had. Thank you. Well, for the watching then, it was for the video. It's so that you have everything split into multiple parts, so that it's easier to. So if one thing fails, then everything doesn't fail. You're not dependent on the Raspberry Pi.
It's easier to reason about than piling them all into one.
Right. If I want to debug the laser tripwires, I can disconnect the Arduino, and I can work on the laser tripwire set.
Yeah.
Well, I have 3 other guys that are working on the other Arduinos, and someone else that's tinkering with a board. So when we were in our rush situation, that really helped, because the Raspberry Pi was a hot commodity. I mean, whoever got whoever had control of our web console, like that was just, that was the spot to be in when we were developing this. And towards the end we had like 4, 5, 6 people at a time in that last month that were all working on it, so. And we had all kinds of ideas, like we were thinking of maybe attaching a monitor to the outside and having it be have puzzles on the monitor, but then in the end we decided that we just wanted hardware puzzles. And so the trick would be to disable the hardware sensors. And then some things we didn't end up using, like we have a flex resistor, and we wanted the flex resistor so that we could detect if the lid was open even when the ultrasonic sensor was not working. And there's definitely room to grow in the box. And there's even talk of making it more similar to Keep Talking and Nobody Explodes, and getting rid of the wood altogether and just doing everything on the suitcase on the inside so you can pick it up and turn it around. But I don't think that'll work because this sturdy box by itself got manhandled too much and barely works now. So if the box was just a suitcase, that would be a lot more difficult, I think. And we'd have more difficult power concerns. Yeah, any other questions then? Yeah?
Is there a particular reason you decided to use TXR USB versus, say, I2C bus?
I didn't know about I2C when we started this. Yeah, now at my job, I work at Control 4 now, and I do hardware testing, and I use I2C every day. So doing this again, that's one of the changes I would do. Yeah, it would be a lot easier.
Could you explain the difference?
So the way I have it going is the Arduinos know which one they are because they're reporting, each one of them is reporting a heartbeat that has their name inside of that heartbeat. And if you were to use I2C, you would have a USB cable, and the USB cable would have an address hard-coded inside of it. And so you wouldn't have to scan, I wouldn't have to listen for the heartbeats to know where the Arduinos were. I would just know from the USB cable, because each Arduino would have its own specific USB cable it was connected to.
Or you could just go I2C direct to the pins on the Raspberry Pi. So the Raspberry Pi would have I2C bus, which have to go to your modules.
Granted, then it would probably be a bit quieter most of the time unless the Raspberry Pi is full of devices.
You have devices for every device.
Yeah, but there are all kinds of considerations that we're going to do. This is our first iteration of the project, and doing it again will definitely have all kinds of optimizations like that. Yeah. Another question? Steve? Okay. Well, that's all I have then. If you all want to come up and look at the box, poke on the inside. It's not solvable, but yeah. Come on up and see what it's like. Thank you.